Today, we will not only make one agentic AI application, but also build MCP from scratch and agents as well. We will combine MCP agent and our LLM and build a complete agentic AI application. Welcome to my channel Bionic Algorithm. If you have not subscribed to my channel, please do subscribe because I'm going to create a lot of content related to AI and this new technologies. Let's understand what we are building today. You might have faced problem to figure out where exactly your file is. Sometime whenever you need your important documents stored in your hard drive or in your computer, it is difficult to figure out where exactly they are. So what we do, we try to search, we try to go to different folders, different files. Well, how about building one AI application where we can just put our query and it will tell us where exactly the file is located and what are the other files which is located in the similar name. Well, that's the application we are building today. Before that, we will try to understand how does the agentic AI application looks like. Let's think that we have one LLM. This is the LLM and we have our local machine here, right? And this local machine is based off Linux as OS. Linux has its own advantage of using it. You can look at my video of why using Linux here in the I button and you can understand why it is important to use when you are a developer. This is our local machine. And this is the LLM. Now what we have to create is one agent. In this case, this is the agent which can search for the file what we are looking for. So this agent is managed by this MCP. We have this MCP which is connected to this agent. There can be many other agents. We are just building the very basic. Then your LLM is connected to the agent and here you as a user stand asking question to your LLM. So this is the architecture what we are going to build. So the user asks for a file to the LLM will reach out to the MCP server and MCP server will give all the agents to the LLM. Now LLM will instruct MCP to use this specific agent we have mentioned, and when the MCP server runs the agent, it basically fetch the details of the file and send it to the MCP. Now MCP send those details to the LLM server and then LLM responds back to the user. Well, this is the overall architecture, but let's try to understand a little bit more details. How the agent is going to fetch the file from the Linux server or from the Linux machine or from any machine. In Linux machine, there are some commands known as ls-ltr. It is basically listing the directory. Just like you do dir or list the files inside a Windows operating system. If you run this, it is going to list all the files inside a specific location. If I run ls-ltr in the root directory, then it is going to give me all the files and the list in the root directory. I have to append this specific command to a file, which is, let's say, in this case, I'll write just kb.txt. In this kb.txt, I'm going to append all the file. If we look at the kb file, it's really big because it indexed all your files. Now what we have to do, because this kb.txt is a text, we have to figure out some way of creating embeddings. If you don't know embedding, then do let me know in the comment box. I can give good links to understand and read about embeddings. So these embeddings, we are going to create using some of the transformer based model, which is a local model. We can use a Hugging Face local model and we can make use of it. Once we create this embedding, we convert our query, the query asked by the user, to also an embedding, and we do one embedding search, or we can say cosine search between the query embedding and the real embedding. Then we try to find out top 5 queries which is similar to the queries what user has asked. Well, once we find out, we return that whole query which is similar to this, and then this query will go back to the MCP server and the server will do the complete task. Well, this is the overall architecture. Let's try to understand this in more details while doing the coding. So this is my Linux operating system, and the first thing what I have to do to build any kind of application is create one Conda environment. So in this case, I'm going to use Python 3.11 because MCP as a module support Python 3.11 and higher versions. To do that, I can do Conda create -n and the environment name is MCP_env and Python equal to 3.11. So if I run this command, I am going to create one of the file. I have already done it. And once you run this, you will just type Conda environment list and you are going to see the environment created. This is the environment what I have created, and you just have to activate the MCP environment. Once you activate, you will see the MCP environment like this. Now let's navigate to a specific folder we wanted to build our project. So this is the folder where I would navigate, and if you look at, there is nothing at this folder. So the first thing what we are going to do is get the LLM application. So for that, what we have to do is just go to Google AI Studio, get API key, and here what you can do is you can create one API key if you don't already have one. And once the API key is created, we'll just copy this and we will create one .env file. Okay. So here what we'll say, Gemini key is equal to your API key. So your API key will look something like this. You just paste it. All right. I have already created this file in a different name. So obviously I will not be creating this file again. Let me copy my Gemini API key to this server. Okay. And the file what I have created is here. So this is the environment file what I have created, and I just copied the environment variable there. After that, another thing what we need is the LLM. So let me create one folder called as LLM, and inside this I have created this Gemini client. Well, in this file we are simply loading the model and we are sending the prompts to the model and getting the response. To do this, I need these are some modules. I have to install this module, and you can Google how to install these modules. And I loaded the environment variable where my key is hidden. Then I loaded the key. I loaded the model itself, which is Gemini 1.5 Flash model. And I am using await and async function. This is something what I have already mentioned in my previous video. You can look into that also. And I just sent the model object and the prompts. So what is prompt? We will see that, but this is going to give us a response.txt, basically the output of LLM we are going to get from generate response function. After this, let's try to first create the knowledge base. So I have already ran the command. As you could see, this is the file what it is created. This file is having a lot of details inside. It's having a lot of files also inside, and everything in my desktop has been indexed in these files. As you can see, this is very big. And now what we will do, let's try to create the indexing, the embedding vectors, and let's try to write the code for that. So I have already written the code, and this is the code what I have written. So we are using torch module. I'll just go through the functions. This code and everything will be uploaded in the GitHub link. You can just go to the GitHub and download this code directly and start working on it if in case you are modifying anything. But yeah, so if you look at this, I am calling the semantic search query. So what semantic search query will do is it will go to model.encode. The query what user is giving, it will convert to a query embedding, right? So the query is given by the user, and then it is converting to the user embedding. What is the query? Query is basically what file you are searching for. Now what we'll do, we will try to do a cosine similarity. For that, what we need is the chunk embedding. And how is the chunk embedding created? As you can see, chunk embedding is coming from load embedding and chunk, this specific function. If we look at this function, what it does is the file name, basically the file name is here, the raw file name like kb.txt file what we have created. We have loaded the file and we are loading the embeddings, we are loading the chunks and we are returning it. So the file name here is the embedding file name what we have created. We'll come to that now. Load embedding will run whenever you have the embedding file is there. If it is not there, it's going to create the embedding file, right? So what it is going to do, it's going to load the document, split the document and create the embedding. Then it is going to save the embedding files. And how it is creating the embedding is model.encode. What is model in this case? If you look at this, the model is the sentence transformers and this is the small embedding model what we are using to create the embeddings. So the structure of this file is we are creating the embedding if the embedding is not there, and we are storing it. And once we stored it, because the embedding is already present, we are just reading it. Once we read the embedding function, we are trying to figure out the cosine similarity score in this case. And we are trying to get the top k. So k in this case is 3 as I have mentioned. So top 3 highest similarity score I'm going to get here as result. And then I'm just printing those chunks and getting those results. This is the semantic search. And this is the whole fundamental of creating the embedding of your files. All right, now we have embeddings of the file and we have the LLM set. Now let's try to build one MCP server. So for that, I have this tool created and I get into the tool and I'll show you the MCP server. This is the MCP server. Here, as you can see, we have MCP as a module and I'm using fast MCP to create the MCP application. This is the MCP application and this is the embedding files. As you can see, we have already created these embedding files and these are transformers. It is needed because we are loading the embedding files, so we might need the model itself. Again, we have the same function, load, embedding and chunking. And this is the semantic search function with little bit modification. I believe if you read and you'll be able to understand. And this, my friend, is the MCP agent. This is the agent which is going to be integrated with our MCP server. What this agent is doing, it's finding a file in Linux OS. It is really important to write the doc string about that agent, because once we run this MCP server, it is going to have this doc string as, you can say, the identification of the file, right? So what it is doing, it is creating chunks and sending all the chunks, and then it is sending the update of those chunks to in a specific format. Let's try to run this MCP server and see how it is working. So simply what I have to do, I just open the terminal and MCP dev, and the file name is tools. Inside that, file.finder. And once we run this, okay, the torch module is not there. There is no module called as torch. What you have to do is do a pip install. Okay, I think I have already installed. So, so here I'll do MCP dev tools slash filefinder.dev. Once we run this MCP dev command, we will see there is something running in the local host. And I just open the local host and this is what it is running. Let's try to connect. This MCP server is connected. Just ignore the error message as of now. And if you go to the tool and create a list tool, it says this is the file tool. And if I just say python.py and run the tool, it's going to give me some response. Like here in this case, success as a result. But this says that my MCP server is working. This is a debugging interface of MCP where you can just see what is going and what is coming to the MCP server. All right. So we know that our MCP server is working fine. Now what we can do, that we know our MCP server is built. Then let's try to make the main function, which is going to fetch the MCP server and get all the details. For that, let me go and get the main function. This is the main function where the MCP client will be there. So now we have, this is our main function, and whenever we'll run this main function, it is automatically going to start our MCP server. And this is how the studio server parameter is defined from the MCP module itself. And this is what will run the server parameters, right? Now it will wait for the studio client to initiate it, and this is the process what you have to follow to build the studio client. And just like we got all the tools, session.list tools is going to give you the set of tools here, right? Now we have all the tools. We will pass those tools as an information to our model. In the tool description, this is going to give me all the description about the tool. Like I have mentioned about the doc strings. So all these details will be there in this description, in the tool description variable. Now here we have the query, and we are just writing the query. We are just asking the user to give me the file name, what has been given, right? What we are just asking the user of what file they are looking for. Now the prompts, if you look at the prompt, the exact prompt what I have written here is extract just the file name from the query, and we are given the query, right? So the query can be find a file having a name as main and the content is py, right? And the content is Python as an example. So basically we are looking for a file which is main.py. Right, so that's why extract just the name from the query. So it is trying to extract. Return only the file name, nothing else. Just return the file name. Understand the query and create the file name as asked. So if in case you are not writing the file name, then it is not created. Add extension to the file if it is not given. So if you have not given any extension to the file, it's going to create that. As an example, let's say I would say cat image. So it doesn't have any any extension. So it's going to do? It's going to do a cat.jpg or png, depending on the kind of extension what it is using. Then you can tune the files, and you can also tune the prompts based on your uses. Then create extension from user's description. Based on the description what user has given, it is going to create the extension. Now, when we are generating the response, this details with the query is going to get into the model. You see, generate response is coming from this specific module, right? This is having generate response, right? So now it will give only the file name as output. So we are just printing the file name has been extracted. Then what we are trying to do, this is how we need to call the MCP server. The relationship of LLM with MCP is never one way. It's the both way. So LLM is just like your brain, which sends instruction to your spinal cord. If you look at the spinal cord, which holds all the instruction and send it to the all other body parts. So now our hands, our legs are called as agents. Brain is the LLM in this case. Your spinal cord is the MCP, and your hand and legs and everything else is agent, right? So it's never a one-way communication. When you pick something, you also are sending the instruction that some object. Now your brain instructs what next needs to be done. So similarly, we will send multiple information to the LLM and we will retrieve the data as we need. So here all the tool details I am mentioning. I am trying to fetch the right set of tool by calling the session.callTools function. Here it is going to call the tool and it's going to give the result. So result in this case is going to be something like this. And I have just created a one-shot prompt in this case where I have given example. User is searching for main.py file. Result file will look something like this, and the output what I need is something like this. This prompt I am again sending to the model, right? The prompt 2. So the prompt 2 is system prompt. System prompt is nothing but this example, and the result. Result is nothing but the result coming from the tool. This I am sending to the prompt, and then I am generating the response in this case. And whatever response I am getting, I am printing that response. If in case I'm not getting the response, then it's going to throw me the error. Let's try to run this file and see. One more thing we need is the data store, the embeddings what I have created. So this is the embedding file what we have created. As you see, this is the path file. If this file is not present, then it's going to create the embedding from the beginning, which I don't want at this point in time. Now if I run this file, it's asking for the file what I'm looking for, and I'm looking for .env file. All right. Once I hit enter, the MCP server is sending the .env file, and the .env file is found in these things. You can see found in user, in snap, in user, in home config. Okay. So these are the files what it is looking for. Now let's see any other file if I want to fetch. Let's say as an example, demo.txt is one of the file. So I'll run this code once again, and I would say file name is demo and it is a txt file. All right. Now I have not given the file name directly, but it is extracted demo.txt, and it has given me some code. File demo.out found in this file.out. Okay, so these are some of the file what is indexed in our server. Now you can see it has not returned demo.txt. One of the possibilities is because I have loaded so many files. As an example, these snap files are unnecessary for me. I don't use them. So in that case, when you are indexing the file, you just index the folder which is important to us. In that way, you will not send garbage to the data, and garbage will not be the output. We have to always remember garbage in is equal to garbage out. The second thing what we can improve is we can use FaceDB or a better vector search than just using semantic vector search like Cosine search. We can use Phase or ChromeDB search, which is much better than this, right? So, well, this is the whole application what we have created. You can implement the same application for Mac, for Linux, and for Windows with minor modifications. But this is the overall Agentic AI application what we have built in this video. If you have any questions regarding this, do comment in the comment box and like, share and subscribe to my channel, and see you in the next video.